Hey class, hope all you guys have been doing well. I miss all you guys and hope you guys are practicing social distancing and staying safe, staying healthy. If you guys go outside, make sure you wear a mask. Hopefully this quarantine will be over soon and we can have fun in the summer. Until then, this is going to be your first mandatory lesson during the quarantine. So this lesson has 5 examples, 5 tries. Now, because this is a YouTube video, the good thing about it is you guys can fast forward parts that you guys understand, or you guys can stop and slow down, stop the video at any time while you're working on the tries while I give you the examples. So again, today we're going to be learning about similarity. There's 5 examples and 5 tries. So I'm excited. This is my first YouTube lesson. So here we go, guys. This lesson is on similarity, and this is going to be the new chapter, chapter 8. Chapter 7, we're just going to, was the last chapter. You guys aren't going to take a test on that because of what happened, so we're just going to move forward. Okay, so let's talk about similarity and why is it important in geometry? Well, remember we did dilations, and dilations either shrinking or growing an object. That's what similarity is. Similar figures are dilations. So we use it to make toys, we use it to make toy cars, we use it to make model buildings, we use it to make action figures. So let's take a look at similarity, and the symbol for similarity is that squiggle. And similarity is figures that have the same shape, angles, and proportions, but they're just different sizes. Let's examine some similar figures. So we have 2 triangles here. Take a look at the 2 triangles. Okay. Notice something about the triangles. Okay, the left side is 3 times bigger, while the small side is 3 times smaller, which means that not every single side is either 3 times bigger or 3 times smaller. That's what's called proportional. If one side is off, then it's not proportional. So notice that 8 times 3 is 24, 5 times 3 is 15, and 10 times 3 is 30. And that's what similar figures are proportional. If they're not proportional, then they're not similar. So we can make the statement triangle ABC is similar to triangle DEF. Okay, now let's go ahead and apply it. Let's go to example 1. Here we have example 1. Trapezoid KLMN is similar to trapezoid RSTU. Find the ratio of ST to LM. So it's very simple. What is ST? Well, ST is 18, so you just substitute 18 over 7, and the ratio of ST to LM is 2.57. Okay, so let's go ahead and try number 1 on your own if you understand what I just did. So here is try number 1 again. You can fast forward and slow down anytime because this is a video. So here, pentagon ABCE is similar to pentagon KLMO. Let's find the ratio of ED to ON. So let's see, ED to ON. So what is ED? Look for ED. ED is 6. And then take a look at ON. ON is 15. So take 6 divided by 15, and you get 0.4. And there you go. 0.4 is the ratio of ED to ON. Now let's take a look at example 2. Given the following figures, determine if they are similar. Now, how do we determine whether they're similar? Well, remember I told you that if they have the same proportion, then they are similar. So let's see. How do you figure that out? Well, what you're going to do is you're going to take WX to AB, and 24.5 divided by 7 is 3.5. Now, you take the other side, WZ to AD, and you compare them. If they have the same ratio, then they are similar. If they don't, then they are not similar. 17.2 divided by 4, that comes out to 4.3. So because the two figures are not proportional, these are not similar. So let's go ahead and take a look at this figure here. First of all, we have to compare all the sides. So let's first take a look at the upper side, the upper left side. So we're going to compare QR to AB. And so that's going to be 29.7 to 11. And that ratio comes out to 2.7 if you divide it. Now let's go ahead and compare RS, which is the right side, RS to BC. That's going to be 10.8 is to 4. Divide 10.8 by 4 and you get 2.7. So far, so good. Now let's take a look at the last side, the bottom side of the triangle, which is QS to AC. 16.2 is to 6, and it comes out to 2.7. So because all the sides are proportional, we can say the two triangles are similar. And there you go. Okay. Okay, now let's look at a different example. Example 3. Given similar figures, find the length of the unknown side. So let's take a look. What side do we not know? We don't know what Kn is. Take a look at that. So put an X where Kn is at, just like that. And you can take any two sides, but you have to compare the same side. So let's take a look. 5 is to X, so I take the left side, and I start it. Now, remember, you have to go in the same order. I started from top to bottom, so you have to go from top to bottom. So if I go 5 is to X, I can say 5 is to X as 9 is to 34.2, or 12 is to 45.6, or 4 is to 15.2. But I'm going to choose 9 is to 34.2. Okay, so take a look at what I just did. If you guys don't understand, you guys can email questions, or you guys can, again, slow down the video, take a look at what's going on here. So I started from top to bottom. I started from the small triangle to the big triangle. And you can compare any sides. They give you the same answer. So I said 5 is the small, X is the big, right? So I said 5 is to X as 9 is to 34.2. So I did the left side and then I did the top side. And I went from small to big. So now you're going to cross multiply, and that gives you 9x equals 5 times 34.2, which is 171. Divide by 9, and x equals 19. So that's how you find the length of the missing side. Now, let's go ahead and practice this and try number 3 on your own. So here's number 3. In this case, what is missing? What do we not know? We don't know what DE is, so let's put an X on DE. Now, I'm going to say X is to 41.4, and I can pick any of those. I can say 5 is to 23, or I can say 13 is to 59.8. So you can use any one you want. It'll give you the same answer. So I'm going to use 5 is to 23. Cross multiply. That's X times 23 is 23. 5 times 41.4 is 207. Divide by 23, divide by 23, and the answer is 9. You guys got that one right? Good for you. Now let's go back to something that we learned a while back when it came to transformations. If you remember, I talked about dilations, and dilation is a similarity transformation where there is no change in shape, it's only a change in size. So a similarity transformation where size changes only, no change in shape. And if you guys remember scale factor is the change ratio. An enlargement is where the ratio is bigger than 1, and a reduction is where the ratio is smaller than 1 but bigger than 0. Okay. So when something shrinks, it's smaller than 1, but when something grows, it's bigger than 1. Okay, so let's go ahead and apply this theorem. So here, let's take a look. What is happening? So obviously, you can see that the figure is growing. So this is obviously an enlargement. So let's call it an enlargement. Now, what is the scale factor? So the scale factor is going to be just the value of the right side divided by the left side. So 18 divided by 7.2 is 2.5. So the scale factor is 2.5. That means that the enlargement is 2.5 times bigger. So it grew 2.5 times bigger. Let's go ahead and try number 4 on your own. So here's number 4. Again, what's happening? Enlargement or reduction? As you can see, it's getting bigger, so it's obviously an enlargement. Again, pick any number, it doesn't matter. It's always the left side divided by, the right side divided by the left side. So 24.5 divided by 7 is 3.5. So the figure is 3.5 times bigger. Okay. Finally, let's go to the last example, example 5. What's happening here? Obviously, you can see that this pentagon has gotten smaller. So this is a reduction. Again, same principle. Take the right side divided by the left side, which is 7 divided by 17.5. And you don't have to pick 7. I chose 7. You could pick 3, but if you use 3, you have to divide by 7.5. If you use 6, you have to divide by 15. So in this case, it comes out to 0.4, meaning it's 0.4 times smaller. Okay, finally, try the last one on your own, and guess what? We're done with our lesson for today. So let's take a look at this. Again, you can stop the video anytime if I'm moving too fast. So here, again, it's a reduction. Take the right side divided by the left side, 12 divided by 20, and that's 0.6. And there you go. Now, that is your lesson for today. I'll be releasing at least 2 videos a week, 2 to 3 videos a week, and you'll be responsible for the work every time because this is now mandatory. So good luck, and please do the homework that I assign you, and just take a picture of your homework and send it to me on email or download it in the Google Classroom. Or maybe I'll figure out a way for you to do your homework on Google Classroom instead of take a picture and do the work. So here you go. Goodbye.